Steel skyscrapers don't build themselves, and oil rigs don't just stroll onto barges. Of course, 10,000-ton bridge segments don't float and mix themselves into place. However, considering the speed of projects these days, something has to move them, and that something isn't a truck or a crane, or even a team of them. It's a machine so powerful, so precise, and so strangely graceful, it feels like watching a ballet danced by bulldozers. Hydraulic Self-Propelled Modular Transporters, SPMTs if you're short on time, are the underappreciated heroes in the industrial arena. Not exactly vehicles or platforms, they're actually modular systems of pure hydraulic force and are fully capable of sliding buildings through cities and turning megastructures into mobile cargo. You won't even need rails or roads. All you need is pressure, and these wheels will give you fantastic control. You won't find these things pulling into parking lots. You find them under nuclear reactors, under ship hulls, under entire highway overpasses, gently lifting and guiding thousands of tons like it's nothing more than heavy furniture, and at the center of every axle and every inch of movement is hydraulics. It goes without saying that this isn't about horsepower. It's about hydraulic power and what happens when you give it wheels, a remote control, and a reason to move the unmovable. The first hydraulic modular trailers appeared in the 1960s, but by the early 1980s, transportation giants like Mammoet and Shirley refined the concept into what we see today and standardized the modules at container-friendly widths, usually an estimated 2.44 meters, for easy sea freight handling. This design didn't take too long before it subordinated older hydraulic trailers. It's all due to the fact that SPMTs are efficient with more than movement. They can easily accomplish lifting, rotating, raising, and turning gargantuan objects shockingly accurately. A hydraulic self-propelled modular transporter is basically a network of heavy-duty wheel modules powered by hydraulics and guided electronically. Think of them as modular platforms on hydraulically suspended, computer-controlled axles, each capable of swiveling up to 360 degrees independently. Derived from hydraulic modular trailers, or HMTs, SPMTs add their own engines, power pack units, or PPUs, so no tractor is needed. They're built for moving truly massive objects. Bridge spans, oil rigs, reactors, sections of ships, industrial plants, or even spacecraft components unfortunate enough to exceed the size limit of roads. An SPMT is a masterpiece of hydraulic engineering, making waves of change as a transport platform. Seeing it work makes you wonder, how does it work? You see, each unit is made of modular axle lines arranged 2 across and typically 4 to 8 long, depending on the job. Inside each axle is a trio of power, a hydraulic cylinder, a hydrostatic drive, and a steering mechanism. These components actually do way more than just move the machine. You will learn that they actively lift and balance the entire structure since the hydraulic system lets each axle adjust vertically. Following that, it also gets to raising or lowering the platform to make up for uneven terrain. They also do this to arrange a load with arguably pretty impressive accuracy. With multiple steering modes, normal, crab, and carousel, SPMTs can drive straight, drift sideways, or spin in place like a fidget toy built for shipyards. This precision is powered by power pack units, or PPUs, compact engine-based hydraulic generators that fuel every movement, every lift, and every rotation. Both diesel-fueled and fully electric types of PPUs totally get rid of the need for external tractors or power sources. It's a self-contained ecosystem of functions where thousands of tons can be moved without a hitch. You know now that SPMTs aren't built for light work. In fact, they're engineered to move the immovable, so to speak. These machines haul massive bridge segments, swapping out entire spans in just hours instead of days. In industries where delays cost millions, that kind of speed is absolutely indispensable. It's true that the oil and gas sector relies on SPMTs to transport giant refinery columns and platform modules, either to onshore assembly sites or directly onto ships. Their ability to steer and position makes them irreplaceable when moving equipment that's heavy on top of being dangerously unbalanced. But its capabilities don't stop there. SPMTs handle huge generators, turbines, transformers, and wind turbine components, items far too large or awkward for cranes to manage alone. They've even made headlines by moving entire buildings intact. Instead of demolishing and rebuilding entire structures from scratch, SPMTs can slide them into new locations, all without cracking a wall. For anything that's too heavy to fly and too valuable to drop, these transporters are the only option. The load capacity per axle line is generally estimated to be around 44 tons, depending on model and manufacturer, and the top models can deliver up to 60 tons per axle. Surprisingly, even while carrying over thousands of tons, SPMTs crawl at walking speeds. The usual speed ranges from 1 to 5 kilometers per hour when fully loaded. You'll be surprised to learn about all the times the SPMTs managed to solve problems that would have taken too much effort and time before their invention. In 2017, the ferry MV Sewol, an underwater salvage, was loaded and moved using 600 axle lines. This was actually a world record in the sheer level of SPMT technology utilized. Operators don't sit inside the machine. They stand behind remotes. These are ergonomic remote controls, some built into cabins, that manage steering, lift, and braking, all with joysticks and a display, like the Enerpac SPMT's IntelliDrive system. They switch steering modes, monitor pressure, see system diagnostics, and coordinate axle angles, all without climbing up to each module. You've learned that hydraulic self-propelled modular transporters, or SPMTs, are now important for heavy lifting logistics throughout critical industries. In infrastructure and construction, they swap out bridge spans overnight, delivering massive structural sections with precision and minimal disruption. In the oil and gas sector, SPMTs are beloved for transporting refinery modules, offshore rig sections, and pipeline assemblies, often loading them directly onto barges or rail. The shipbuilding and offshore industries likewise rely on SPMTs to maneuver enormous vessel sections, platform modules, and deck components, feats that gantry cranes alone can't manage easily. But their domain doesn't end there. In power generation and petrochemical plants, SPMTs can carry giant turbines, transformers, basically machines that are too heavy, too delicate, or too tall to crane into place safely. They've also pioneered the art of building relocation, shifting hotels, historical structures, and industrial buildings intact across streets or campuses. Even mining and heavy manufacturing sectors can make use of their capabilities to move smelters, crushers, or even massive processing lines that forklifts and conventional trailers could never budge. If hydraulic presses crush steel, hydraulic SPMTs transport it, massive, heavy, and complex. Hydraulic power runs through every axle, every lift cylinder, every steering output. They aren't for everyday trucking, they're for setting entire bridges and sliding buildings. And though they speak the language of force, they do so with subtlety. Lift where needed, swivel when asked, glide sideways, rotate in place, and lower into perfect alignment to finish the job. When your job demands moving what should not move, like massive, awkward living embodiments of gravity, hydraulic self-propelled modular transporters are the only machines built for the task.